Right. Find the points of discontinuity. That's the directions on the example. I put in parentheses vertical asymptotes because they're going to be vertical asymptotes. And that's what we care about. Now, like most everything that we deal with in this chapter, the expressions that you see could be unfactored, and so you're going to have to factor them. That's another thing that makes this chapter harder, right? Because number one, you're going to have to do things like add, subtract, multiply, and divide fractions, which you may not ever have really mastered. Now you got to do it with variable expressions, and a lot of those expressions have to be factored before you can do anything. Okay. Now, most of the factoring isn't too difficult, but some of it is a little difficult. This is not factored. How could I factor it? Wait, somebody else. How do you factor x squared plus 2x plus 1? Blank. Peter. Right, it's what two numbers, the product is 1 and the sum is 2. Remember that? So it's x plus 1 times x plus 1. So in factored form, now, what are the zeros of the denominator? -1, right? So if I set this equal to 0, x equals -1. So x equals -1 is a vertical asymptote on the graph, right? It's the zeros of the denominator. I'm going to keep rolling for the next one. Right? Part of the same problem. Right? How do we find the vertical asymptotes? Again, in the last problem, we factored because it was factorable. Is that factorable? No. Right? If it's a difference of squares, we have a way to factor it. We don't have a way to factor a sum of squares. Now, you could still try to find zeros. Right? You could set this equal to 0 and then solve it. X squared equals -1. Take the square root of both sides. X equals plus or minus I. Now, if we're looking for values of x that show up as vertical asymptotes on the coordinate plane, they got to be real numbers. You know, when we solve this and we get something that's not a real number, then that means there are no vertical asymptotes, right? So, therefore, no vertical asymptotes. Right, so in every case, if you're going to find the vertical asymptotes, set the denominators equal to 0 and solve. Whatever those values are, x equals those values are vertical, dashed vertical lines on the graph.